Holy shit. It is so great to be here. I think it's still, for me, the thrill of interacting in 3 dimensions. I'm still kind of on a high on the fact that we're back and doing face-to-face stuff again. Feels fantastic. It's also just such an exciting time for our industry. It really reminds me of the early 2010s after the great financial crisis. It really is an era of a lot of building, a lot of experimentation, and a huge amount of innovation. So today I'm going to talk about unarguably the biggest and most, maybe possibly most exciting topic, certainly in technology today, certainly in data today, arguably even in society today, which is around AI. And the specific view is around hallucination and what we can do to help reduce or eliminate hallucination when that is appropriate. We're also going to discuss when that is appropriate and when not. But, morning session, some of you have had coffee, some not. So we're going to start interactively with a couple of fairly nuanced and sophisticated questions. So the first one is, what do you see on stage right now? You don't need to raise your hand, just shout it out. All right, once more. Good job. All right. Again? All right. Yes, it's a duck. Yes, it's a rabbit. This is called a duck rabbit. And a bunch of researchers showed this to people, about 250 people. The vast majority of them identified it as a duck in the fall and as a rabbit around Easter. Why? Because it turns out that with language, context really matters. We all know what this word means. 2 characters, O and K. Okay, it's okay. Except, actually it can mean okay, or okay, or okay. It can mean a lot of different things, as it turns out, just those 2 different characters. There's been a lot of research around this, and it turns out that in communication, 55% of understanding is actually body language. 38% is tone of voice. Okay, 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 that part. And only 7% are the actual words that we use to communicate. So we have this really clear picture in our head that we want to communicate to the world. For example, last summer, I had an amazing time going out picking apples with my family. And I say that out loud like I just did. And what you're all hearing is this 7% version, this lower resolution version of that beautiful idea. That's true if I express it talking in spoken word like this. It's also true if I write it down, maybe if I put it on a web page, maybe if I put it on multiple web pages on the internet. We have the beautiful idea in my head. You have the 7% lower resolution version of it spread out across the internet. So let's pause right there and let's talk about LLMs for a while. Large language models. Everyone here, absolutely 100% of all of us, have used ChatGPT, I'm sure, right? And holy crap. Like, if someone would have asked me a couple of years ago, I never in a million years would have believed them. That we're getting this technology, which on some level feels like this alien technology beamed in from the future, or this magic box. It passes the Turing test. For half a century, we've had this one test describing, have we achieved AGI, artificial general intelligence? It passes it with flying colors, but we just moved on and said, yeah, it's fine. It's just this little thing. It's absolutely fantastic in its capabilities. Ultimately, at the core, Its objective function is what's called token prediction. It's a glorified autocomplete. That's basically what it is. Now, amazingly powerful, and we can argue is that what our brains actually are? Are our brains actually glorified autocompletes? But it turns out that it has a number of drawbacks. This is an interesting concept, and once you start thinking about it, you can start thinking like, wait, what did we just talk about? We have this 7% resolution version of a very pristine idea expressed on the internet, and we train these LLMs on billions and trillions and tens of trillions of those web pages. So is that really enough? Well, it turns out that as powerful as these LLMs are, they're also not very powerful sometimes. They make real mistakes. This is a famous example. You ask it, hey, it took me 1 hour to dry 5 shirts. What about 10 of them? And it actually goes into advanced math and calculates the fact that it's going to take 2 hours for 10 shirts to dry in the sun. And, you know, like a 2-year-old would be able to figure out the answer to that. A more personal example, when ChatGPT first came along, my wife asked me, who is Emil Eifrem married to? I'm a somewhat public figure. There's a lot about me on the internet, right? She's not, at least not under her maiden name a little bit, but not under her like new last name. And so ChatGPT responded, Emil Eifrem married Johanna Eifrem in 2011. And I did get married in 2011, but Johanna Eifrem is my cousin. I did not marry my cousin. But GPT just happily made up the answer to that with this amazing autocomplete objective function. So we have this really beautiful idea in our head, right? And when I say we have this beautiful idea, it's actually because this thing that I have up here in the center of the head, that apple thing, is a very simplified version. What's actually going on in our head is that an apple isn't just an apple to us. We relate that to different things to create context. We say, you know, an apple grows on a tree. It is a fruit. You can use it to bake apple pie. You can use it to do cider, apple cider. It has context. It has other concepts that it's related to. So what if we could then take this really rich contextual understanding of a concept and combine it with that low resolution yet powerful ability to describe an idea in natural language? What if we could get computers to relate things and relate concepts in the same way that the human brain does? Of course, it turns out that we can. There's a concept called knowledge graphs, which has been around for a while, and it's doing exactly what we just said. It relates the concept, the cognitive understanding of the human brain. It puts them in context and relates them. So what is a knowledge graph? So the term got popularized by an amazing blog post by Google in 2012. It's amazing because of the content of it, but also because of the really succinct 3-word summary. They said, we're going to introduce the knowledge graph on our web search. The biggest upgrade they've done to web search since they founded the company on a graph algorithm called PageRank. This was the biggest upgrade. They said, we're going to shift. We're not just going to search for strings. We're also going to search for things. Things, not strings. And what it is very practically, you all know and feel, and it's just a natural way of how search engines works these days, which is you search for Web Summit, you don't just get the links based on the strings in the documents on that search page, you also get this panel. And this panel extracts some structured information, in this case about Web Summit. It is in Lisbon. It was founded by Patty, David, and Derry. The CEO is Catherine. It's in the Altice Arena. You know, that kind of stuff. That little panel is backed by a knowledge graph. And in this case, the knowledge graph looks like this, right? We have Web Summit. It's founded by these 3 founders. Catherine is the CEO of it. It's located in Lisbon. Lisbon is located in Portugal. You can go into the panel. You can click on Lisbon. You're going to get that panel for Lisbon, which then you can click to Portugal. And you can navigate the knowledge graph through the consumer web interface of Google. This is a knowledge graph. In our world, we call the circles, we call them nodes. They describe the entities. We call the arrows connecting them relationships. And we call the data payload, the attributes, we call them properties. And with those three building blocks, you can model everything. You can model an e-commerce transaction graph, right? You have locations and products and components and customers. You can model, circle in, zoom in on those customers and connect them to leads and marketing campaigns and your support tickets and Zendesk users. You can create a digital twin of your entire physical enterprise, because it turns out that any company that's producing a lot of physical goods has a lot of connections in that. You have an airplane engine which fits into an airplane. That engine in turn consists of many, many parts, which in turn consists of many, many parts. You can connect that entire product hierarchy to your supply chain, and then you can analyze that, a digital twin of your enterprise, and you can build out a product and parts graph, right? These are great examples of many different domains that you can use to model with a knowledge graph. But what can you then do with it? We have all kinds of amazing technology in the world of data that is fantastic at summarizing numbers, calculating aggregates, calculating averages, things like that. What graphs are really good at is answering arguably the big questions, right? In all my data, what's important? In all my data, what's unusual? And in fact, given the patterns of the data, predicts what's next, what's going to come up. All right, so that's generic. This, however, is the full stack stage. It's a stage, I think, full of builders. So let's be a little bit more practical and tangible. I'm going to model out, give you an example of a support forum. In a support forum, when we model that, all of data starts with things, and things are represented with nodes. For a support forum, like you can think Stack Overflow. People can ask questions and answer questions. All the questions have tags. So we model that using nodes, the users and questions and answers and tags. They have properties like the actual question being asked, maybe the time it's being asked, things like that, right? And they're all related. And the questions are tagged with tags. The user can both ask a question and provide an answer to a question. We describe that with relationships. Voila! And there you have a knowledge graph. So that's fantastic. But now what? All right. We started out with LLMs and hallucination and some of the reliability problems with LLMs. And then we talked about knowledge graph. So how do I combine the two? How can I use the knowledge graph to stop my LLM from hallucinating? All right, I've got one word for you, and that's RAG, which is retrieval augmented generation. All right, raise your hand. Who here has heard of RAG? So maybe 10% or something like this? I'm going to do a really quick crash course on what RAG is, because RAG is a really, really big deal in how you build LLM-backed applications in 2023. So the crash course of RAG is, it is the best way today for the vast majority of applications to give an LLM access to your data. So I'll caveat right away. I put like the today in here, because this space is moving so freaking fast that who knows 6 months from now where it's going to be. But today, it's the best way to be able to give an LLM access to your own proprietary internal data, which on some level is maybe the killer use case, or at least the first use case that people want to do when they build LLM-backed applications. Second of all, and really, really important, it's a developer-centric architecture. If you think back in the year of 2023, which has been such a whirlwind of conversation about the power and lack of power of LLMs and how to use them, it really is a tale of two cities. It's a tale of two halves. The first half of this year, the conversation was dominated by, all right, how large, should a large language model be? Is 100 billion parameters enough? Is 1 trillion parameters enough? What's the end of scaling loss? Do we see a future of one big God model, or should it be an orchestration of SSMs, small specialized models, right? How does that all fit together? That was the first half conversation. that really was the arena of the ML researcher, the ML engineer, the data scientist of the world. That was about how do we produce these large language models. In the second half of the year, the conversation has shifted to, wait, I can treat the LLMs as a black box. If I have a proper architecture together, all of a sudden I, as a developer, as for example a full stack developer, can then build applications on top of this without being an expert at how to actually build and train and fine-tune large language models. That's the second piece. And then the third one, this does not require any fancy work. You can get going today, right now, like after this talk. Not during this talk, but after this talk. So this is how it works. Let's say that we're building this support application, this chat forum, like I want to log on, I have a knowledge base internally of support articles, and rather than having a human being read from that to my end user, I want the end user to be able to ask it, right? So that's the application we're building. So we have a user, and it starts with that user chatting with my application, asking a question, and the goal is to give a really fancy LLM generating answer, but based on my own internal enterprise's knowledge, right? So step one, we get a chat message from the user. We then run that through an embedding generator to generate a vector version of that question. Why do we do that? Because it's a really smart way of looking up those knowledge-based articles. For that, you need a database, however, that supports vector search. And vector search used to be the exclusive arena of the vector databases of the world. But today, most databases support vector search. Neo4j supports it, Postgres supports it, MongoDB supports it. So then you go in, you find the relevant documents based on your vector search, and in the case if you're using a knowledge graph, you can then combine it with graph search to find even better and more accurate documents. You take them, you pass them on to a vanilla LLM, pass it on to not a fine-tuned, not anything fancy, GPT-3.5 Turbo, GPT-4o, right? Llama 2, a vanilla pre-trained LLM off the shelf. You treat it as a black box. As developers, we have a really long history with being able to look at components as black boxes and just work with them. The weird part here is that the API is English. It's literally natural language, which is emerging, by the way, ironically, as one of the most popular programming languages in the world today. English, right? How crazy is that? So we then get the summary back from the LLM that we then pass on to the user, right? This is really, really simple, right? You don't need to be a fancy machine learning researcher to do this. You just need to be, like me, a developer. So we did some work with a few companies, Docker and LangChain and Ollama, to put together a stack for this that we announced about a month ago at DockerCon, which is this pre-configured set of components using Docker containers that you can just, bam, download. You go to the GitHub repo, you clone it, Docker compose up, and you're up and running. You have LangChain, which is this framework for building LLM-backed applications. You have Neo4j in there. It uses Ollama for local LLMs on your laptop if you want to, or you can connect to the ones over the internet. So what I'm going to do now in the remaining 4 minutes, because when you are short on time, I think you really should launch into live demo time. So I'm going to give you a shot of what this actually looks like. Yes, all right. We're off to a great start. All right, I'm going to assume that the AV team is sorting out the flickering. And looks like we're up and running. So what this is yes, we're up and running. So let me go into full screen here so that you see this. So what we've done here, this is that same support application that we talked about yesterday, where I've actually downloaded data from Stack Overflow. So this will be very small for you to see, but that doesn't matter. Here you can see we have questions, we have tags, and here in purple we have answers, right? And we can expand them. We can look at here. There's going to be a bunch of LangChain questions. We can look at them, we can expand, and we can traverse that. This is using vanilla Neo4j, and this is what we're going to back our RAG-based application on. All right. So let me see here. I'm going to go to the small little UI, and I'm going to see if, hopefully you can see this. I have two modes here, RAG mode disabled or enabled. Disabled doesn't use the knowledge graph at all. It just goes directly to the LLM. So I'm going to start there. I'm going to say, how can I create a chatbot on top of my local PDF files using LangChain? All right. It goes directly to GPT-3.5. I don't know if this is visible, but it says, I'm sorry, but I don't have any information on how to create a chatbot on top of local PDF files using LangChain. Why? Because LangChain was created after the cutoff date of GPT-3.5. So I'm asking the same question, but now I'm enabling RAG mode. So now it goes to the knowledge graph, gets the data out of that, some of the data here, right? And it passes that to the LLM, and lo and behold, it says, you know what? To create a chatbot on top of your local PDF files, blah, 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 1, 2, 3, 4, 5. But not just that, it also provides links here at the bottom, the source for their answers, which provides that transparency and explainability that is such a big problem with LLMs right now, that there are these opaque black boxes. All right, flip back to this before the demo crashes in some way that I can't foresee. So what we saw here then was really two halves of the brain of an LLM-backed application. On one hand, we have this magic capability that can speak natural language, it can generate text, it's creative, right, which is amazing. And on the other hand, we have this technology, the knowledge graph, that is great at explaining what it's doing, that is providing facts, that is providing deterministic facts, whereas the LLM is great with probabilistic guesses. And that one is not better than the other, but the match together is just really, really fantastic. We are not the only ones seeing this. Gartner is saying by 2025, 50% of GenAI initiatives will have improved reliability and transparency by combining large language models, foundation models, with knowledge graphs. This is not a theory. This is something you can get up and running with today. This is a room full of builders. This is what's so exciting about this time right now. So please take up your phone, take a photo of this QR code, go to this GitHub repo, and start building amazing, explainable, accurate, LLM-backed applications. Thank you very much.